any function and its inverse essentially undo each other. For instance, if we had x cubed, and then we took the cube root of that result, those two operations would essentially cancel each other out, and we end up with just the x that we started off with. Similarly, if we started off with x and multiplied by 2 and then divided by 2, those operations would cancel each other out, and we'd be left with just x. Exponentials and logs are inverses of each other. So in this first statement, if we have a raised to the log base a of m power, that exponential and log would just undo each other or cancel each other out, leaving us with just m. Similarly, if we have the log base a of a to the m power, we have a log base a and an exponential base a. Those two pieces would cancel each other out or undo each other, and we'd be left with just m. So those are two handy notions to keep in mind when we're looking at rewriting log functions or log expressions. We also have rules for breaking up different log statements. For instance, the log of a product equals the sum of the logs. What that means is that if we have the log base a of m times n, we can split this up as the log base a of m plus the log base a of n. So rather than multiplying those two factors together and taking the log, we can split that up into the sum of two separate log statements. The log of a quotient equals the difference of the logs. This is similar to the property above, except now we have m divided by n. So we'll end up with the log base a of m minus the log base a of n. Multiplication and addition are connected. Division and subtraction are connected in those two properties. We also have that the log of a power equals the product of the power and the log. Which essentially tells us that if we're taking the log of some expression with an exponent, we can rewrite that exponent as a factor in front to, in this case, get r times the log base a of just m. Each of these properties applies for any log function or any log expression and can be used in specific ways to rewrite or help us solve log equations. In example 5, we want to simply rewrite the log base 6 of 36x as the sum or difference of logarithms. In this case, that means we would get the log base 6 of 36 plus the log base 6 of x. And from there we can simplify one step further because we can look at evaluating the log base 6 of 36. If we were to rewrite this, this would be the same thing as saying 6 to some power is equal to 36. And in this case, we would have to take 6 squared to get that result. So this would mean that we could rewrite this as 2 plus the log base 6 of x. In example 6, we want to rewrite the natural log of e times x plus 9. Again, we have the product of two different factors, so this would become the natural log of e plus the natural log of x plus 9. We can look at evaluating the natural log of e, just like we evaluated the log base 6 of 36. This would be the same thing as the log base e of e, which would mean there's some value that we could raise that base of e to get e, and our result there would be y equals 1. We can generalize this a little bit into just another property, which is that if we have the log base a of a, that result is always going to be equal to 1, because a to the first power is always equal to a. The natural log of e then is equal to 1 plus the natural log of x plus 9. In example 7, we want to rewrite the log base 3 of x to the 5th power. We can bring that power as a factor down in front to rewrite this as 5 times the log base 3 of x. And then in example 8, we have the quotient of two terms inside this log, which means we can break this up as the natural log of x minus the natural log of e to the x power. In example 9, we have a more complicated expression, but we can still apply these rules piece by piece. First, we have the quotient of two different expressions, meaning we'll start off by rewriting this as the log, and since there's no number there, we can assume that this is log base 10 of x times x plus 5 minus the log base 10 of x plus 3 to the 10th power. Now we can focus on those remaining log statements and break them down just a little bit more. This would be the same thing as the log base 10, and now we'll just skip writing that base and let it be assumed. This would be the log base 10 of x plus the log base 10 of x plus 5. And then we'll bring that exponent down as a factor in front to rewrite this as 10 times the log base 10 of x plus 3.